Hello and good afternoon, everyone. Welcome to today's Career Discovery presentation on coding with Bank of North Dakota. I'm Stacy Holzheimer, University and Student Development Coordinator at Bank of North Dakota, and I will be leading you through today's webinar. During this session, attendees will learn about coding as an industry, including web and software development, examples of jobs you can get, and different types of education to get into a coding career. Some quick housekeeping items. In the menu of the webinar, there is both a chat and a Q&A function that we encourage all of you to use for the questions or comments that you have about today's webinar. We will answer questions at the end of the webinar, but please put them in a Q&A when you have time. It is now my pleasure to introduce to you our speaker today, Blaine. Blaine is the Program Director and Full Stack Instructor at Emerging Digital Academy. EDA is an immersive software engineering bootcamp in Fargo that trains entry-level software developers in the practice of building business web applications using modern software engineering processes and web technologies. Blaine is a software engineer with a passion for education. He lives in Fargo with his wife and son and is interested in continuing to build EDA into a world-class institution that serves the needs of our local economy and citizens by providing an alternative path to a career in North Dakota technology industry. Welcome, Blaine, and take it away.
Great, thank you. Hello, everyone. Happy to be here today. What I'm going to talk about a little bit this morning, this afternoon, will be just kind of a general overview of what it looks like to work as a software developer. Talk a little bit about some of the educational paths to that career, and happy to answer any questions in general about type of work and if anybody has just general questions about the industry. My contact information is up on the screen. You're welcome to shoot me an email if you've got any questions, and I'll talk a little bit about EDA at the end, just if you're curious about that as well. So a quick note here about myself. I've been in Fargo for 7 years. I originally came from Cincinnati, Ohio. My background is, let's see, I went to school as a computer engineering undergraduate program at the University of Cincinnati and studied computer science in grad school. I ended up creating a small consulting company and pursued that for the last good part of a decade, and then recently switched over to education, help out with EDA. I've been doing web development for about 20 years, which is crazy. So almost all of that is self-taught, although I self-taught on the web side and then kind of backed up with some of the traditional formal education on the theory side. So really love software development in general, love staying up to date with web technologies. My focus is very much on the web, not so much on some of the more, I guess you could say, hardware or lower level systems, although I've worked with those as well. Find them fascinating, but most of my time has been spent building software that touches the internet in some way. So kind of moving through here. So software is everywhere. We kind of know that. And really over the last 60 years, the practice of software engineering has grown exponentially by the decade, and especially with the invention of the internet, things have changed a ton in the last 20 years. And even the last 5 years, really. Trends have accelerated. We see dozens and dozens of different programming languages and technologies and frameworks and ideas and patterns. And all of these things are creating this really cool and really sometimes frustrating, but also fascinating dialogue around how do you build good software? How do you, create infrastructure and systems that are secure, but also are able to stay on top of user expectations. We are all now pretty sophisticated users with mobile devices and laptops and desktops, and there's a lot of expectations that we have, you and I, as regular users of technology, that we expect software to work well, we expect it to be easy to use, and so a lot of web development and web technologies is focused partially on the engineering and technology side, partially on that overlap of user experience and actually accessibility and all of these other kind of components, which is kind of fascinating because that's a lot different maybe than some of the larger scale, mainframe and older, kind of like 1970s, 80s, and 90s technology versus, maybe what's more web related. One cool thing that I'm fascinated by is this innovation of the web. The internet means that anyone can build software right now that can be accessible to billions of users through their mobile devices and computers. So that's kind of like, you think about it, that's a big deal. It's not just a big deal, but it's kind of a new thing. Up until the invention of the internet, you had to put it on a CD or a floppy disk and go sell it in a store and hope that people can find your software and install it, right? Now you just go to a web page, just download an app, or don't even download an app, go to a web app, use it on, use it in your web browser. So it's a pretty crazy world, and it's a lot of really, really interesting and cool things that you can do. So I like to approach software development as a craft. I recently heard this kind of a phrase that said, a craft is basically anything that you can get better at. So it doesn't necessarily mean you're talented or have some natural gift. Those things help, but you practice at something, you get better at it, you learn, and through hands-on practical implementation of studying something, a craft becomes something that you level up in as you continue to work with it. Programming is hard, of course, but it is not impossible. It just takes time to figure out. It's basically like problem solving and puzzles, and there's a lot of things that come into play when you're trying to learn and to understand the all the different pieces. But what I would say is, in general, if you're considering a career in software development, there's three things that I would suggest that you ask yourself if these are things that you find as a personality trait. There's a fourth one that's not explicit in this slide but is implied, and we'll talk about that as well. But essentially, if you like problem solving and creativity, it could be a path for you. A lot of software is pattern matching, where you take some existing solution and you try to figure out how to apply that to some other problem. However, no solution is turnkey, meaning you will always have a component of creativity in how you think about, well, I have problem set A and I see a solution over here, but I'm actually working on problem set B. How do I apply that solution combined with other things that I've seen in the past in order to fix that problem over here that's maybe related but not exactly the same? And so a lot of it is there's a ton of creativity that comes into software development, because it's kind of a mix of things that work combined with being creative and how you use the tools that both weaknesses and strengths of those tools to accomplish some goal. I would also say grit is a really important component to any technical study, but especially programming, because this stuff's hard. You might struggle for days or weeks or months on the same problem. And so what really sets folks out that are really good at this stuff is they just don't give up. You see it as a challenge. So me personally, I find it's certainly frustrating to not be able to see through something to the final answer. But what I will say is that you should be able to at least reflect on the learning process and find satisfaction in the challenge of seeing something through to the end and not giving up. You might have to spend 10 hours Googling around and finding rabbit holes of other people from what they have done to solve some solution. But at the end of the day, you find that you see that as a means to an end to ultimately arrive at some final answer to the problem you're trying to solve, versus just finding that to be a frustrating experience and not continuing. So grit is really important, again, for any technical study, not just software, but any kind of STEM, and any kind of engineering or science and math, right? Those are all hard things, but you just keep practicing and you keep moving through it until you succeed at that. So grit, and finally resourcefulness. So much of modern software development, especially, the answers are not in a book. There are great books that you read. You learn a lot from books, of course. But so much of it is just studying the process of learning, studying how to fail early, meaning arrive at solutions as early as possible that might not work for what you're trying to do, so you can move on and build from there. And of course, building frameworks for knowledge systems. So what I mean by that is, as a programmer, you are not expected necessarily to have everything memorized. So I have a lot of, for example, programming languages that I've learned 5-10 years ago. If you ask me to write software in that language right now, I probably wouldn't be able to do it, but I know that given a day or two of study and of retracing the paths and of finding familiar ground, I could do a quick survey of those things, remind myself of how they work, compare those to things I'm working on today, and remind myself of those, similarities to get to a point where I could almost certainly be functionally competent in those technologies and reload them into my head so that I could start working on those. As a programmer, you are expected essentially to be a lifelong learner. So that means that you never stop learning. You're always spending part of your time reading, part of your time watching trends, learning from your teammates. Not having an ego in your in the practice of software development is important, because it's not. There's kind of another phrase too. It's like you are not your code. So your code might have bugs. That doesn't mean that you as a person have bugs, right? That just means that the code you wrote can be better. And so that practice of continually improving your craft to just write better software, solve problems more efficiently, reach for the right tools is super important. And so it's not something where you study at a university or go through a program and then you're done. No, that's not the case with anything, but especially software. You should expect to be essentially continuing to learn, continuing to grow over the course of your career. And if that's not exciting for you, might not be something that would be a good fit. What kind of work do software developers do? So this is kind of open-ended. I'm going to just run through some examples. But what's crazy to me about some of the modern software development practices is that software is everywhere. So it's not so much anymore that you pick some programming language and that's what you work on for the next 20 years. It's not really the case. I mean, there are so many custom systems, there are so many high and low level problems to solve. Every business has stuff they might have built by themselves, stuff that they might have sourced from a third party, stuff that might be off the shelf and needs customization. At the end of the day, that's all on the table as far as what somebody might be focusing on. It might be pure software development. It might be using problem-solving skills from experience in software development to do tasks or projects unrelated to something that you've done before. And so what I like to think of is software is just a tool. And so in a lot of ways, our job as software developers and as IT professionals, information technology, right, really is to solve business problems. That's it. So certainly you can write code as art. You can have it as a hobby, right? That's fun. I love playing around with new technologies and trying to create generative art. I think is a fascinating area, but that's more on the kind of the hobby and artistic side. The reality kind of day to day of what you're doing as a working software developer is you're solving business problems, meaning the code itself is not the product in a way. The product that you are working on is adding value to your customers, to the business that you work for, and understanding the holistic kind of approach to a company, to a team, to an enterprise, and by using software to essentially make money, save money, to acquire new customers, to make the lives of your existing customers better. It's just a tool. It's one of many tools that you would use. And so I think that it's easy to think, all I want to do is, sit in a basement and stare at a computer and code all day, right? But the reality of it is there might be jobs like that, but that's not how you grow as a software developer, as a professional. The way that you grow is by integrating with a team, working with real people and other humans in order to solve problems that exist in the real world. Certainly there are toy projects and things that, like I said, you can work on for fun, but the general day-to-day work of a software developer is innovation, efficiency, and continual learning. And so entry-level positions might have you, just simply writing code all day and not really talking much about the rest of the organization. But that's what's kind of cool about modern software development and really technology is it's embedded everywhere in the world, right? And so your real job kind of coming through this is to understand the context of how software works, to understand the problems that your skill set might be able to help solve and to ultimately be a part of the larger organization that you're working inside of, which I think is very interesting, because that ends up showing you a ton of different kinds of work you can do. That could be actual software development, that could be customization and deployment of software, that could be security and cloud computing. I mean, there's so many different things. We haven't talked about mobile software or even gaming, right? All of those things are all different specialties that you can focus on. So let's look at a couple jobs that you can do in software development, right? These are going to be job titles. A lot of times these overlap with each other. Just some examples of things that you might see out in the world. Software engineer, pretty typical job title. Often a software engineer, notice I'm not talking about specific technologies, because a software engineer might have a ton of different things that they do depending on the industry. But in general, this is kind of your core software development. So you're going to be working on systems, you're going to be working on bug squashing, you're going to be, day to day is essentially evaluating new features for a customer and evaluating potential problems with a system and working on that. A lot of it's open-ended. A lot of that work is, having to figure out on your own how to solve problems and be an efficient and excellent team member. But a lot of the software engineering kind of general idea is focused on system reliability, custom needs, and business impact. So for example, if you work at a company that does software for agriculture technology, right? Your day-to-day might be working with those customers, working with your team, evaluating, all the different systems that are supporting the farming and agriculture, components that are out there in the real world. It might be evaluating new potential mobile interfaces for those systems. It might be running reports and looking at a long-standing laundry list of bugs that come up in special cases, right? It might be evaluating future trends in technology to see if you can add those to your product or project in order to, create value in some other way. And so a lot of the software engineering role itself is very dependent on the company and the process that you're working in. Some companies might do consulting. So software engineer at a consulting company might be responsible for designing, implementing, and testing software. If you're at games are always a good example because we all love playing video games. Software engineer at a video game company would likely be responsible for the code that actually goes into making the game, or they could be responsible for the deployment and the packaging of how games get distributed out, or could even be working on the back-end systems of how to place orders in a game, or how to, do the microtransactions inside the game, that goes off to some system to process a payment. I don't know. So it totally depends on the the role inside the company that you're looking at. Full stack developer in a lot of ways is a software engineer. I call that, I just use this term, it's kind of a modern term. Sometimes, it's kind of a funny thing, but full stack really usually means that it's somebody who doesn't have a specific focus on one part of the technology they're working on. They actually have a holistic view, and oftentimes it's related to the web. So by full stack, we're typically talking about somebody who really enjoys web technology. So I consider myself to do full stack a lot. I like back-end database systems, but I also am really interested in web technologies, HTML and CSS, making the web browser, interactive and following best practices. I think a big thing about full stack development is really acknowledging that you're not doing a lot of custom things. You're typically using best practices on top of existing software that is usually helping you save time and then move on to the next project. It's pretty typical. Lots of different programming languages, lots of different things. And like I said, most full stack developers overlap very cleanly with software engineering. But software engineering doesn't necessarily mean that you're related to web technologies. So full stack developer typically is more web focused, front end and client, back end database all together and kind of understanding the ins and outs. Another example would be front end developer. Again, could still be software engineering, but a lot of times front end is more of a specialty where you're focused on user interfaces. You might have a design and art background. You're focused a lot on the web browser, the mobile interfaces, the things that the visual and interactivity. Basically, when we say front end, we're talking about what the user touches in the web browser on the computer. Front end developer, and a lot of times needs knowledge of the back end systems. They might become closer to full stack over time. But a lot of times front-end developer can literally just be a specialty into everything web. staying on top of design and user experience, capabilities and trends, with the intent of essentially being responsible for the interfaces that a user uses when they go to a web page. So think about any of your favorite apps, any of your favorite websites. Front-end developer is going to be the person tying all of that together, looking at design inspirations, working with web designers and artists to implement a lot of those things, and finds that work interesting, not tedious. That's the thing. A lot of traditional software developers might not want to even touch any of the art assets and that kind of stuff. They want to focus on database and back-end systems. So a lot of times with the web especially, it's really important to be able to overlap with the art and design teams in your organization. A couple more here we'll kind of run through. I find it fascinating to take a technical background and apply it to more of a systems analyst role. So this is somebody who's taking a holistic view of all of the different pieces in an organization, but might not actually be writing much code necessarily. They're more, kind of looking at analysis, performance reports, and trying to understand how things connect and work together. But coming from a technical background, it's important because a lot of technical roles in industry might not actually be writing code, but it requires the knowledge of how the systems connect, which is kind of fun. Might have quality assurance. These are teams inside of software companies that often are responsible for automation, for breaking apart systems and putting them back together, for analyzing why things fail and how to report that back, maybe even fixing those things themselves. A lot of times a quality assurance and testing role is really knows the most about a system because they know how to break it. They know how to, if I were to give you a package of software and say, hey, does it work? Is it going to fail? Is the customer going to be happy? Quality assurance is going to run through that and hey, say, let me run through my 5,000 tests automatically and tell you what your code broke when you introduce that change. And so that's a oftentimes, QA and testing is part of a software development role, but could be a specialty inside a larger team as well. DevOps is kind of a newer thing. It's a mix between development and operations. It's another specialty that you could get into after you get into industry. But the general idea is, imagine you have a piece of software, but you want to put it up on a cloud computing system. How do you secure that? How do you make sure that updates to your code can end up, being distributed out without downtime? How do you monitor those running systems and make sure that that code that you just wrote is actually, not causing your software to run slower? All of these things are part of the modern infrastructure for cloud computing. So a lot of it is analysis, monitoring, and there's a whole specialty into just how the heck do you, monitor and manage all of these running systems. A lot of times it's the developer. So like in the old times, you'd have like old times, right? Like before modern practices, you'd have the development over here and you'd have somebody running it over here, and they don't really talk to one another. They just say, hey, the new code's out, go run it on the server. And then when something breaks, come let us know about it. Well, DevOps is kind of more of a philosophy that says, well, if you're writing the code, you should also probably be responsible for getting it up in the cloud as well and running it to make sure that the same people who are responsible for developing features are also making sure that they're keeping in mind the constraints of the cloud environments as well. So it's kind of a fun one. Business operations, you can, a lot of, I'm thinking of a colleague of mine who started as a software developer, but does a lot of basically IT and e-commerce work. And so software development comes into play because a lot of the systems need customized and reporting can be generated on the fly, but they're not actually writing the e-commerce software. They're using off-the-shelf software for that. So that's an important role as well. And I think just the last one's product owner. This is more of a management role where you might start off as a software developer and get more into the business side of things, where it's kind of like, I'm going to work with my development team. I'm going to work with marketing and sales and the executive team in order to produce things that are applicable to business needs, but maybe you're not actually doing the software development yourself. And so these are all kind of like different parts of an organization that uses software as a part of the organization, but maybe isn't, but is doing a whole bunch of other stuff as well. Okay, so just last few slides here. Software development typically pays pretty well. Average entry level salary in North Dakota is about $52,000 a year. We know that from the just labor statistics in the state, and that tracks with the national. It's actually a little bit under the national level. It's probably around $60,000 a year nationally. And that's entry level. So again, assuming that you as a software developer keep up to date, go to conferences, keep investing in your training, that can lead to a growth path that ends up, just being a great professional path. I just looked this up nationally. The $107,000 salary is about the median for all experience levels. So I think that 10 to 15, 20-year range for folks that are still doing software development that haven't gone on to management or other roles. And a lot of that is skewed, of course, by high-paying technical roles. At kind of the West Coast, East, we call them the coast companies, right? A lot of those salaries are way more competitive, so they pull that number up. But overall, though, it's a great field to be in. Has a lot of room for growth. And I'm down to my last couple of minutes here, so I'll just do a couple of quick slides. How do you become a software developer? It's a great question. I always tell people you can start right now. Go to freecodecamp.org, start learning. MIT has all their computer science courses online for free. You can go check that out. Code Academy, it's a great resource as well. They got a bunch of free online things, and I always like the Odin project, just another kind of totally full online course that you can check out to learn full stack development, but just programming in general. But you can start that stuff now. Figure out if you like it, if it's something that you want to invest more time in. It's one of the best times ever in the history of computing to learn programming, because there's so many great resources. I always recommend folks learn, build, make mistakes, and repeat. Throw them into a portfolio. Start early, start getting that under your belt so you can get some experience there. But whether you go to school for it or you work on your own, you can start working on that as soon as possible, because you will learn so much just by number 4 there, making mistakes. You learn what not to do. Traditionally, higher education is a great path. Computer science or computer engineering will always provide a great path. It's a larger commitment on time-wise, but you learn foundational and theory, right? Typically, you're not learning industry trends. Usually, you're learning more foundational things in order to create like a lifelong, basically, foundation of learning. Some folks end up going for some other major but minor in computer science. So I always think that's fun. Mixing some specialty with programming is always fun. Art or math or physics, business with a computer science minor is always a good idea. A lot of folks are self-taught, somewhere around 40% of most professional developers are self-taught in some way. Well, not in some way, like most ways, non-traditional background. A lot of times you'll learn on the job as well. And then kind of what we do, EDA is what's called a software boot camp. So it's a 5-month full-time, accelerated path. Less focus on practice, less focus on theory, more focus on just like building software and getting code out the door so you can keep working on your own. So a lot of different ways to kind of get that going. Just a couple more slides here. Software development is hard. So that's just a reality of it. It's a rewarding profession, but it's challenging. So it's nice to learn early, whether it's something you'd be interested in through those resources I mentioned. But lifelong learning is a key part of that. And here's kind of a general summary. Lots of paths to becoming a software engineer. You can start now. Career in coding can unlock lots of career paths all over the place, take you strange places. And finally, it's an in-demand field, crosses over many industries, and it's just another tool for your toolkit as you kind of continue going through your career. Okay, so I ran a little over on squeezed out some time for Q&A, but hopefully you found that interesting. I'm happy to answer any questions now, and happy to respond over email as well. I've got my email address right here. And yeah, thanks so much for tuning in.
Thank you so much, Blaine. And if anybody has any questions, please put them in the question or the chat box right now. Blaine, we do have a couple of them. First question is, and I think I know the answer, but I'm still going to ask, can you work remote in the majority of these positions?
Short answer, yes. I'm remote right now in the basement of my house. And software development is one of the industries that is, you can very much work remote by default. It takes more communication, certainly takes some, trust. So entry level, not always remote, but once you work inside of a company for a couple of years, it's very typical to, and gain the trust of your team. It's very typical to be able to work wherever you want. There's these digital nomads, if you will. It's kind of a trend happening where as long as you're getting your work done, as long as you are accessible and communicating well, doesn't really matter if you're in the office or not, because you're doing all your work online through video conferencing and deployment and all of that. Like you can access your servers and your code from anywhere in the world as long as you have internet access. So definitely 100% definitely remote capable.
Okay, perfect. Thank you. So these two kind of go hand in hand. I'm going to ask the first, how do I get exposed at an entry level to coding to know if it's of interest to me? I think you touched base a little bit on the different websites. And then the next question says, can you intern or have an apprenticeship to see if it's a career that I'm interested in? So kind of molding those two together. What are your thoughts on maybe kind of an apprenticeship or going alongside someone, or how to figure out if it is, if someone's thinking this is what they want to do, but they're really not quite sure? What would your advice be?
Sure. So I think there's two parts. The first is, are you interested in the work? And so you can, like I mentioned, start that now, start working on programming just to see if it's something that interests you. You can do that for free. A lot of awesome resources online to go through that. And so that'll at least help you understand if it's something you might be interested in. As far as job shadowing, it's a great idea. I think my recommendation, other than watching YouTube videos and following along with other folks, kind of, because there's a ton of YouTubers and people that are talk about their jobs in software, but I would say honestly, it's kind of a funny excuse, but just reach out to folks in your community, ask your friends and family if they know anyone doing software development, or find people randomly on LinkedIn and just reach out. I think a lot of times folks are always willing to answer questions and grab coffee or virtual coffee to kind of talk through about what they do kind of on a day-to-day, and that also shows a lot of initiative. And so if I look back on my kind of career over the last, since I came out of high school, one of the first things I got started on was joining a job shadow program through my high school. I thought I wanted to do IT, ended up job shadowing an IT group. It was okay, realized it wasn't really what I wanted to do. I wanted to do more creating software rather than just running and maintaining software. And so that helped me learn early that there were different kind of specialties inside there. So I would say reach out to folks that you find, or and just try to see if you can kind of just learn more, interview, treat it like a project. Spend 10 minutes grabbing a virtual coffee with someone, just ask them what they do day to day and kind of what they like about their job, what they don't. That'd be my recommendation.
Perfect. Good advice. Okay, we've got one last one that just came in. So when it comes to colleges, what should we be looking at when comparing a college's computer science programs? Is there much difference between a 2 and a 4-year program?
Wow, that's a great question. Difficult to answer. What I will say is that here's a dirty secret in software. So much of what you learn in the class doesn't really matter. It's really important, but what really matters is what you do outside of class. What I mean by that is studying the history and the context of everything. It's important. What really matters is the practical part of building software. So the best students that we see coming out of university, if you're looking for a new entry-level developer, is someone who probably did okay in school, but also they come with a portfolio of work and they can talk about it. And they say, here's a hackathon I went to on the weekend, and here's what our team did. Because what it shows is that you're not just doing it academically, you're really interested in the work itself. And that's why self-taught programmers are a thing, because what really matters is what you can build and what you're competent at. So with that being said, computer science programs are awesome. The 2-year programs are good too. You just have to make sure that to get the most out of a 2-year program, I'd recommend coming up with a plan that you're doing alongside that program to make sure that you're building relevant software outside of the classroom. And the one piece of advice I will give everyone, because I didn't realize how important this was, my undergrad, University of Cincinnati, requires internships or what are called co-ops. So they don't have a 4-year program, they're all 5-year programs. And it's required that once your sophomore year starts, every other semester you work full-time at a job until you graduate. That is key. And so what I would say to you is, if you are not able to do the projects outside of the class, at least try to get an internship while you're in school, because it's a very theoretical and kind of heady academic environment, which is awesome. But to perfectly balance that, you should seek to build software on your own through either professional experience or through these hobby projects that I mentioned. So otherwise, yeah, I think most computer science programs, what to look for, look at what they're researching, look at how their graduate program, is running as well, because a lot of times the same professors that are teaching your undergrad are working on cool projects with their grad students in the graduate programs, and just kind of get a feel for the kind of focus of them. But in general, I think a lot of the computer science programs, they're going to teach you similar ideas, great foundational stuff, but it's really going to be up to you to do the outside work. Like I remember being taught, I was told by one of my professors, I said, hey, why don't we do anything on web development? Isn't that important? And he told me, yeah, but that's your job. Your job is to go learn the awesome stuff that we know you can do. But we know you can do that. You bring that to the table if that's what you want to focus on. We'll teach you all the foundational things to provide a lifetime of learning. And I always found that fascinating. So they're just different approaches to the problem. But at the end of the day, really what matters, unless you want to go into research and academics, which is awesome, what really matters in industry is what you can build. And so seek to get that going as soon as possible. Yeah.
Okay. All right. Perfect. Thank you so much, Blaine, for joining us today. We really appreciate it. And thank you everyone on today's webinar for taking some time and joining us. Our next career discovery webinar is Tuesday, November 10th at 11 a.m. About applying for North Dakota Dollars for Scholars scholarships. And I will be leading that webinar. You'll be able to learn about the benefits of creating your Dollars for Scholars student profile early, updating it often, and then applying for scholarships throughout your entire college career. We'll also be walking you through how to create and update your specific program. All students who graduate from a North Dakota high school or who are home educated in North Dakota are able to apply for scholarships through North Dakota Dollars for Scholars. And you are able to register for the session on the Career Compass website at careercompass.nd.gov. That's all we've got for you today. Thank you so much, everyone, for joining us. And again, Blaine, thank you so much for taking time out of your day today. I know you are a busy, busy man, so we really appreciate you being here with us and answering these questions and providing some clarity around this specific area. So thanks so much and have a great day, everyone.
Yes, thank you.
Thanks. Bye.